Okay, so now we have set up our project in ideally environment, and we have written a simple test case or test class. And in this video, what we're going to do is we're going to go in detail of how to create a test class, the various annotations that are available, and the various assertions that we can make while testing your software. Okay, so let's first start with what is a test class. Okay. So as a programmer, we interact with the unit testing framework, which is nothing but the Jupyter framework, which we have imported via test classes. Okay, we create a test class for each test case that we want to test, or for each feature that we want to test. Okay, so in the previous version of JUnit, consider JUnit version 3 and 4, a class in a test class is considered to have a certain characteristics. That is, it should be public. There should be a no argument constructor. You should define a no argument constructor, and there should be at least one test method. Okay. Uh, in the latest version, that is JUnit 5, okay, we some of these constraints has been relaxed. You don't have to have your class to be public. Okay, you don't want you. It's not necessary that your class should be public. You can make them package protected. So, what do you mean by package protected? That is, let's go to the example that we had. You can see that the test class that I've created over here is called as a calculate test. Okay, so this is a test class that we have created, and I define this class as public. Now, this was a requirement in JUnit 3 and 4. In JUnit 5, you can make this as package protected. A package protected is nothing but a default case or default access case in Java. Okay, so even if you have this as the same test class without providing a public, you can still run the test defined over here. You can see the results there. So both my test cases has passed. Okay. It's no more required your test classes or test cases classes that you define to be public. It can be package protected, and package protected is nothing but your default access specifier that you don't mention anything. Okay. Now going back to the presentation. Yeah. The second thing we have done is JUnit 5. Another thing that JUnit 5 relaxes compared to JUnit 4 and 3 is that is the second thing that you should have a public no argument constructor. Okay, a constructor with no arguments. That was compulsory in JUnit 3 and 4. Again, over here, there's a relaxation. You don't have to provide a constructor at all, or publish. So we know that if you do not provide a constructor, by default, Java provides its own constructor, okay, its own default constructor, which is the class name itself, which is char C, and it is public in it is a public constructor, which has no arguments. Okay, so you have this constructor, so you don't have to provide this. And this constructor, not only that, it can also have arguments. So okay, in JUnit 5, you can have your constructor to have arguments. And the JUnit 5 constructor can be package protected, similar to the class access specified. The JUnit can also be, it can be package protected, also protected. Okay, you can define it as protected also. Okay, both can be there. The earlier cases, that is in JUnit 3 and in JUnit 4, it is required to be, you're required to provide a public, okay, it is required to provide a public constructor with no arguments. It was compulsory that you do this. Okay, from JUnit 5 onwards, then it is not compulsory. So JUnit 5 also gives you the option to provide parameters. Okay, it gives you an option to what, provide parameters in. So how parameters are provided? Okay, so to provide parameters in JUnit 5, all you have to do is we make use of a particular class called test info. Okay, let's import that class first. So yeah, we make use of a class called test info, and we cannot just add any parameters into my constructor. Or you have to provide a class of the type test info. Okay, and this test info argument or parameter can be used to get various properties of the test. For example, we want to know what is the display name. Okay, we'll come into what display name is, but we want to know what is the display name of, or what is the name of this particular test. Okay, so I can have a system.out.println. Yeah, I can have a system.out.println and use test info and use the display name. Now, display name is nothing but the name that is displayed over here. Okay, currently the name is, by default, is always going to be the name of my class which I provided. So if I run this test case once more, okay, this time you can see over here, for each test, there's something else printed. That is, what is the name of that particular test? So this particular test case or this test class has two tests, right? One test is called test add, and the name of the test is test add. Another test is called test sub, and the name of the test by default is always going to be test sub. Okay, I can override and provide a different name for this particular test. For example, I can use at another annotation called at display name and provide a name, say for example, addition. Okay. Similarly, let's give a different name for the test case for my subtraction test case. So at display name, let's call it subtraction. Right. Okay. Now when I run the test class or test cases, if you look into output, you can see the name that was printed. So what is actually, by looking this, what is actually happening is for every test that is being executed, a new object is created and the constructor of that object is being called. That is why every time for every test, so for the first test add, a new object of class calculator test is created. So all this is done by the framework itself. Okay, object of the class is created. By creating an object, what happens? The constructor is called, and by calling the constructor, I'm displaying the test info and I'm displaying the name. And the name which I provided for the test called test add is addition. So that was printed first. Okay. After completing that particular test, okay, I went on to the next test and I printed the display name for that particular uh, test. Okay, so another annotation called as display name to provide a display name of a test that is right below it. Okay, for a function which is right below it. If you do not provide the display name, okay, what will happen? The what display name is basically your function call, function name itself. So if I run this once more, you can see over here, for both, say the first one, the display name is addition. The second one is the function name itself because I have not provided a display name. Okay. Okay. So, what this test info is called? It is called as a parameter resolver. Okay, so this parameter resolver is automatically resolves any parameter that is sent to the object. So if you look at this particular constructor, okay, I have no idea what is the object which is because I'm not creating the object for each test. It is done by the framework automatically. So because of that, earlier version of JUnit does not allow you to create a parameterized constructor. But over here, it will let you create a parameter constructor, but by making use of the parameter resolver and the test info class that you have imported, okay, the test info class that you have imported, is a parameter resolver class which takes the information and makes use of the information that is provided as a parameter. Okay. And we use that display name annotation that allows us for using meaningful names for the different tests that we create. Okay. Now, what are test methods? So we saw what's a test class. A test class contains a constructor. Similarly, every class can have various test methods, and each test method is considered as separate tests. Okay, as separate tests that you run. Okay, so tests in JUnit must be annotated using the class that is JUnit. So in JUnit 5, okay, in JUnit 5, you should annotate every test that you could. So any method you define for a test should be annotated with a class called which a class called org.junit.jupyter.api.test. So by using this annotation called test, the function that you write right below it, that is, I've used the annotation of your, okay, I've used the annotation of your, the function that you define after that would be a test. Okay, it will be a test that you define. Now, the previous version of JUnit, similar to test classes, previous version of JUnit, the test method requires certain certain characteristics. One of that is it should be annotated with a different class called or JUnit test. So if you're writing tests for JUnit 4 and 3, it uses a different annotation in a different package. See over here, the package is org.junit.test. Okay. But if you're using writing test cases based on JUnit 5, then the annotation is junit.jupyter.api.test. So that is one thing. Another restriction that is provided by JUnit 4 and 5 is that all tests should be publicly visible. Okay, but in JUnit 5, it is no longer required to be public. That is the test that we have wrote at a moment. Okay, both are public, which was a requirement for JUnit 3 and 4. Now it no longer required to be public. So if I even remove the public keyword, if I go to the default access specifier, which is nothing, default access specifier, and if I run the test, oh, sorry. Okay, let me run the test once more. Okay, if I run the test, you can see the test still runs and it still passes. Okay, it still runs and it still passes. Okay, so it no more required to be public. Uh, Test cases should not take any arguments. That is still there, and it should always return void. So these two restrictions are still there in JUnit 5, but other two restrictions changed a little. That is, the first case we have a different annotation that we need to use, and the public visibility restriction has been removed. It can be either be protected or package protected. Okay, it can be protected or not private. It should be protected or package protected. Okay, now, uh, yeah, let's move on. So we saw text classes, test methods. Next, let's move on to assertions. So what are assertions? We already saw assertions over here. Okay, so we're going to assert and say assert equal is assertions where we provide an expected value and we run a particular function or we run a particular feature that we have implemented and we check and see whether the feature that implemented outputs the expected value. And if both are equal, then this is considered to be what this assertion what if it is equal this assertion succeeds or else this assertion fails. Now if the assertion fails, then we consider that the test case has failed or the test has failed. It's not an error. It's there in that case if the assertion fails. So for example, my expected value was 4. I'm just randomly changing over here, and when I run the test, what would happen is what this particular assertion would fail. You can see it fails over here. And this is not an error. What it's shown is not an error. It's just saying that for the particular feature that we have implemented, that is within the calculator class, I called a function called add. I passed in a few input values and I expect to get a value 4, but what it provided me is the value 3. So there's something wrong with the implementation, that is, I'm not getting the expected value. So what assertion does is, assertions either succeeds or fails. It succeeds if the feature provides us with the expected value, and it fails if the feature does not provide us with the expected value.